Hello, my name is Anna Lou, and you are watching my presentation on how to improve student performance on the SAT math test at Willowbrook High School. So let me just take you real quick through the plan of attack. I will briefly talk about what is the problem of practice here surrounding the learner-centered problem. I will discuss the current research on this problem of practice and suggested instructional strategies to combat it. And then I will discuss implementation and timeline for the action plan, and then how we will evaluate the success of the action plan and its implementation. So for starters, just so that you are aware of what Willowbrook High School looks like, there's a picture here of the front part of our building, and we have a little breakdown of what our student population looks like. So we have just under 2,000 students at Willowbrook High School, and it is a very diverse school, actually number 2 in diversity in the state of Illinois, and you can see that on screen. It is a middle to low income area, and we have about 50% of our students on free or reduced lunch. So what you see on screen now is a grade distribution for my third hour Algebra 2 students at Willowbrook. Now, I have 28 students in this Algebra 2 class. This is a junior level class, and you can see on the chart that 25 of those 28 students are earning an A, B, or C in the 70, 80, or 90% range. This is indicative of the success that we see with our students in our junior year courses, not just Algebra 2, but many of our core courses. This breakdown is fairly representative of what we see in most classes, and that is success for the majority of students. We provide great supports. We have very solid curriculum, and we have wonderful instructional techniques and all the tools of technology to enhance our instruction. So, where the problem becomes clear is when you look at the connection between our junior year students, their math grade, and the connection between that and the score that they earn on the SAT math portion, specifically zoning in on the Heart of Algebra subscore. When I did run the regression analysis for just the SAT math score and the junior year math grade, the correlation was so weak it wasn't even at an R value of 0.1. So I did run it again with the data that you see on screen and found that there was a correlation of 0.173, which of course is still incredibly weak. Furthermore, if I do take the outlier student scores out, that would be the one student you see on the left side of the screen who is at a 53% in class and has a 6 on the Heart of Algebra subscore on their SAT math portion. If I remove that student, the correlation does go up to 0.203. So there is a connection, there is a correlation between a student's performance in math class and their Heart of Algebra SAT math subscore, but not a strong one, not a deep connection. And there should be when the content of junior year math classes very closely aligns with the Heart of Algebra questions on the SAT math test. So this is bringing to light the learner-centered problem here, which is that students are learning the math content presented to them in their classrooms. In many cases, they're actually mastering this content, but they don't seem to have the skill sets required to demonstrate that mathematical understanding on SAT or standardized test questions involving math, which is intricately linked to the problem of practice. which is that teachers really need to explicitly teach mathematical problem-solving strategies in class that are effective for standardized math tests. It is clear that students are learning the skills that are being taught in class if we take the time and the effort to ask the teachers to focus on a particular problem-solving strategy to teach students. We know that it is possible for the students to learn that and then be able to demonstrate their knowledge on a standardized assessment. So take a look at the current research on screen. I'll give you a moment to look. So the three research studies that I looked into most closely are listed on the screen. And the first one, comparing and discussing multiple strategies for solving a problem using worked out example pairs to help students develop greater procedural fluency in their and flexibility in their mathematics. That is the one that I ultimately choose for the instructional strategy I would like to implement in my action plan. It did lead to greater scores in many different areas of mathematics on standardized assessments. So we would like to see those results for our students, of course. And the worked example pairs are really a very concrete way to teach students the kind of mathematical thinking that we already as math teachers want them to be able to do. Now, the other two studies also offered wonderful strategies for teaching students problem-solving techniques that would be helpful for standardized assessments, but there were pieces of the picture that would not make it as easy to implement both of those and might not yield as high results. If you take a look at the instructional strategies breakdown here on the screen, I explain how the impact is medium to high if we tried to do some metacognitive math strategies. The research did indicate that there were moderate gains, and the feasibility is medium to implement such a strategy. And then employing scaffolding techniques is definitely a high feasibility. It's something that would be very doable for most teachers to be able to tweak what they are already doing with scaffolding to improve and hopefully get some of those results indicated in the research study. However, the results were not as marked. So the most bang for your buck is going to be the strategy in the middle, where we have high feasibility and high impact if we teach our students how to work through these worked example pairs and start to see the value of different strategies for solving mathematics problems. So what our classrooms will look like and what our teachers and students and what their work will look like if we do implement these activities with fidelity. I've outlined that all here in the table on screen. And what I'd like to point out and highlight is that you would see teachers using these WEP activities more regularly in class. You'd see a lot more prompting of students to compare strategies. And you'd see a lot more guiding of students through the discussion to help them make the connections and see the differences and similarities in the methods and the value of one over the other. In the end, you would also see students being pushed to summarize the big idea of the lesson. And ultimately, we would hope that students would be able to demonstrate higher procedural flexibility as the research indicates they will. We also expect that they may be more likely to have eraser marks on their work and have second attempts at solving due to the fact that they have learned the value of knowing multiple strategies for any kind of problem solving they need to do. So now we come to the action plan that I'd like to implement to help improve learning and teaching in Willowbrook High School mathematics classes. So again, I've outlined here what the learner-centered problem is and what the problem of practice and instructional strategies would be to address that problem of practice. What I want to point out is the timeline that I suggest this could be done on. And basically, we start out with the math department chair arranging for a professional development session, both the time and the expert or coach to come in and effectively teach these problem-solving strategies through WEP discussion and activity. We would start with that first session, and then after that first session, the math department chair would want to implement the WEPs in their own classroom, and then invite all the math teachers in the department to come observe his class during these WEP discussions. That would hopefully take some of the fear, trepidation about trying something new out of some of the teachers' minds, because they would have watched their department chair try it already. And then in week 3, we would want to ask teachers, all teachers of math, to try one activity minimum. And then in week 4, we would have the math department meeting begin with a share aloud from all of the teachers on the results of them trying at least one WEP activity that previous week. And then at that point, when the discussion wraps up, the math department chair would offer some guidance for the next round of WEP implementation. And he will suggest that for weeks 5 and 6, teachers try to implement a different style of WEP activity. Some WEP activities ask students to think about which strategy was done correctly, which one was done wrong, which one is better. Some ask, why does it work? How are they different? We want to get kids thinking about different aspects of the solving of problems. So we ask students or teachers to experiment with those other types. And then in the following week, we would have some teachers who are feeling enthusiastic about these activities record their lessons to be able to capture some good examples of these strategy discussions. And then the following week, in week 7, math department chair would need to bring that coach back for a second session. And in that session, we would want the math teachers to take on the role of students in class, completing these WEP activities in pairs or small groupings, and get them to experience what it is that they're asking their students to do. After that, the math department chair would want to summarize all professional development so far in week 8, and then include some of those video clips that his teachers had generated a few weeks prior, and share all that out with the math teachers so that they have additional tools and examples to work from. Then in weeks 8 and 9, we would ask math teachers to try doing at least 2 activities in class. After that, we would have math teachers go to their PLCs and design more WEP activities for upcoming units of study so that they'll have them banked and ready to use going forward. Then in November, when we get to weeks 11 through 13 of the school year, we would ask that we get to the point where math teachers are doing at least one WEP activity every week, and hopefully with some kind of variety, not the same type each week. By the end of November, math teachers, together with their department chair, should be able to evaluate how was this action plan implemented, and do we need to continue on the same path? Is it working, or do we need to seek additional professional development, perhaps even from another provider? So in the end, that evaluation is really going to come from 2 main sources. One will be the anecdotal evidence from math department teachers and the chair. And the second will be from the department chair and the data team analyzing the growth in students' math standardized test scores from previous years to this year. So we would want to see if there is a statistically significant improvement in math scores that could be attributed to these new WEP activities being implemented. So I would like you to consider my action plan and the results we could potentially have for our Willowbrook High School students, and hopefully be able to get them to a place where they'll be able to demonstrate the mathematical knowledge that we know they have built, and do so with greater flexibility in varying different environments. Thank you so much. Goodbye.